Good morning, children. Today we are going to discuss about classification of elements and periodicity in properties. Actually, why we need to classify the elements first of all? What is the reason behind of that? In order to classify the elements, first we need to know that generally, if we will go to any shop or any library, any super bazaar, if we will go to that place, what will happen generally? So, if we observe here, generally what we need to get here. So, actually, what are the things are going to happen? So, actually, what is going to happen means when we go to the medical shop, generally we are going to purchase some medicines. We will ask the person who are in the shop to give some medicines itself. Otherwise, if we will go to the super bazaar, at that time also we will ask. Otherwise, we will go and pick some provisions what we require generally. So, because of that reason, generally, if we will see there, the arrangement of medicines, otherwise the arrangement of uh, provisions, if we will see in these figures how the medicines are arranged, otherwise how the super bazaar fruits and these provisions are arranged generally, we clearly able to see here. I means in the 18th century we have only 31 elements at that time, but on day by day what is happening, the elements are going to be found, new elements are coming, new elements are inventing. So because of that reason, what, so many elements with so many properties, different properties introduced. Because of that reason, there is a definite arrangement could be required in order to arrange the elements itself. In order to arrange the elements, different scientists, they have different thoughts. They have came with different innovations, different ideas. So based on that, the scientist Mr. Dobereiner. Actually, he proposed one periodic table. Similarly, Mr. John Newlands, after that Mendeleev, after that Moseley, like that, so many scientists they have proposed different type of tables, periodic tables, based on the different properties, based on their atomic weights and atomic numbers. We will discuss it further generally. So, periodic classification of elements, if we have seen classification of elements. Now we are going to see here generally the arrangement of elements into different groups on the basis of the similarities in their properties is called as classification of elements. Already we have seen earlierly the medical shop photograph, we have seen library also and super bazaar also, related to particular category that was kept in a particular rack itself. Similarly, based on the properties of the elements, these different type of elements which are related to the similar properties are kept in a particular slot itself. They have arranged in that manner. So the classification of similar elements into groups makes the study of elements is easier. So if you have keep the elements in a particular manner in a different rack which are based on their properties, by means what, the elements which are having with similar properties, if you're keeping in a particular row or particular column, it is easy to identify the elements. It is easy to pick up the elements which are having a similar properties itself. So there are right now, I mean so far, we have 114 different elements known so far. So we don't need to know that what are the early attempts at classification of elements. The earliest attempt to classify elements was grouping the known elements, about 30 elements, into two groups are called metals and non-metals. By means what? Initial days. Earlierly we have discussed what 31 elements are there in the 18th century. At that time, most of the people they can know that we have only metals and non-metals. The defect in this classification was that it had no place for metalloids. And by means what? Metals classification is there, non-metals classification is there, but there is no place, there is no classification regarding the metallites. Metallites in the sense what? Which have the properties of metals as well as the non-metals, which were discovered later. So after, by arranging of the periodic table also, so many different type of elements are coming. By means there is an clear idea, we need to give the place for the upcoming element also. We need to arrange different periodic tables. So based on that, different scientists they have given different ideas and different views based on their ideas. So based on that, if we will observe the periodic table, the first periodic table, if you are going to observe, the first person is Mr. Dobereiner. So how he given the periodic table, how he constructed the periodic table, let's once we will observe. So if you will see here, Dobereiner classified the elements in the increasing order of their atomic masses. If you will observe here, at the time when the Dobereiner constructed the periodic table or observed the periodic table based on his periodic law, at the time atomic numbers are not invented. They don't know what is atomic number at that time. So because of that reason, Dobereiner classified the elements in the increasing order of their atomic masses. So how he is constructed the periodic table? Let us observe the periodic table right now. So the first column, if you will see the triad itself, second column is atomic mass, and the third one is average atomic mass of the first and the third element. So the major thing is what? Dobereiner constructed the periodic table based on the increasing order of their atomic masses. Meaning itself what? For example, if we see the first triad, tri means what? Three. So three elements which are present in one box, that is called as the triad. It is arranged lithium, sodium, potassium. If we will see the atomic masses of these three elements, that is in increasing manner. Once you see the second column of atomic mass, once it is 6.9. After that, in an ascending adder, sodium will be 23.0 itself. Similarly, potassium, if you are going to observe, that will be 39.0 itself. By means, it is definitely in the atomic mass increasing manner. So the periodic table by the Dobereiner, which is constructed especially based on the atomic mass increasing manner, right, itself. Now, what is the principle he suggested in his periodic table? So he arranged the periodic table and atomic mass increasing manner. But what is the periodic law which he has used in the periodic table? Let me know that. In each triad, the atomic mass of the middle element, that means what? First triad, if you'll observe, the atomic mass of the middle element. What is the middle element in the first triad? Lithium, sodium, potassium. In that, the middle element will be sodium. The atomic mass is how much? 23. Let it be, no problem. So what he's saying, in each triad, the atomic mass of the middle element was approximately equal to the average atomic mass of the other two elements. What are the other two elements in the triad? Lithium and potassium. So let's do the average of 6.9 and 39.0. So probably we are getting the average value of 23. We are going to write it as what in the third column? 22.95. Atomic mass is written 23.0. We are considering as 23 itself. In the similar manner, second triad, calcium, strontium, barium. Similarly, third triad, if you will see, chlorine, bromine, iron. So every triad he constructed based on which principle? The middle element was approximately the atomic mass. If you observe the middle element atomic mass is exactly the average of first and the second elements. So is it generally must and should we need to appreciate the Dobereiner first of all. Either the periodic table is it is correct or not, whatever it may be. We need to appreciate the Dobereiner. Why? Because he is the first person to construct the periodic table for the elements in the world. Because of that reason, we need to appreciate the Dobereiner. But why we need to at the same time we have to we are getting some defects in the periodic table also in his periodic table. What are the defects if you are going to observe here? Generally, he constructed the periodic table based on the principle in an atomic mass increasing manner. Right? It's what is the defect? The defect in this classification was that all then known elements could not be correctly arranged into the triads itself. That means what? Some of the elements only arranged in the form of the triads, but not all the elements. By means what? If we are doing a work, definitely that work should be finished. And definitely the work what we are doing, the periodic table what he has constructed, that is applicable for all the elements. This is not happened. Because of that reason, this law has some limitations, some drawbacks. By means, what is the major drawback? It's not applicable for all the elements which are known so far. Okay, so because of that reason, Dobereiner law of triads, what he has constructed based on the principle, it is appreciable because he is the first person to invent the, to construct the, to give the law into the periodic table phenomenon. Okay, so this is the first periodic table if you are going to observe it. Similarly, If we will see the second one, after completion of Dobereiner periodic table, the second person came. He is Mr. John Newlands. So, how John Newlands was constructed his periodic table? What idea makes he constructed the periodic table? So, already we have the drawbacks in the Dobereiner law of triads. That means what? All the elements which you are not getting, those are the elements are not constructed in the form of triads, the Dobereiner periodic table, Dobereiner law of triads. Because of that reason, so I'll also try. Let me try to construct a new periodic table with a new law. He came with a new assumption. He came with a new law, to new innovation. He has tried. So, like that, what will happen? Newland law of octaves. Octaves in the sense oct means how many? 8. So we will discuss regarding the Newland's periodic table, regarding the person, where he was, from where he was, and what he did, what is the law. So based on that, if we will observe, John Newlands was a British chemist. Newlands found that when elements were arranged in the ascending order of their atomic weights. Students, once you will observe here, previously Dobereiner was constructed the periodic table based on their increasing of the atomic weights. Similarly, the same phenomenon is taken by Mr. John Newlands. By means what? Atomic weight increasing manner only Dobereiner constructed the periodic. Similarly, atomic weights increasing manner only John Newlands is going to construct the periodic. Okay, right. When elements were arranged in the ascending order of their atomic weights, they appeared to fall into 7 groups. Each group contained elements with similar chemical properties. Based on these observations, Newlands proposed the law of octaves. The law of octaves states that when elements are arranged in the ascending order of their atomic weights, they fall into the pattern in which their properties repeat at regular intervals. Every 8 element starting from the given element resembles its properties to that of the static. So this is what just we are reading the Newland law of. But what is the meaning of that? How he has constructed the periodic table. Dobereiner already we have discussed. Triads will be there. The average mass of the first and last element is equal to the second element. That is the law of Dobereiner. But what is Newlands now? So this is a pattern. We will see the periodic table of Dobereiner, Newlands, John Newlands. So John Newlands octaves, if we will see generally, what is the John Newlands octaves means? He arranged the periodic table into groups. That means what? One column he will take. In that column, it will be what? Exactly, it contains 7 elements in that. In the second column, it has more 7 elements. If you'll observe the first element and the 8th element beside of that, which is first element will be in the first column, the second one, third one, fourth one, like that 7 elements we will write in the form of a column. After that, the 8th element we are going to write beside of the first element. At that time, if we will see the properties of first element and the 8th element, second element and the 9th element, third element as well as what? 10th element. By means, every element is resembling its properties with its 8th element. By means what? The first element and the 8th element are having similar properties. In this manner, John Newlands is constructed a new periodic table itself. That's why 8th element is resembling in its properties now. Because of that reason, 8 means oct means how much? 8. Because of that reason, the law is stated as law of octave. So once again, I am saying John Newland law of octave. You will observe here, every 8th element starting from a given element, by means first element and 8th element, the resembles in its property. Resembles in the sense what? Having similar properties to that of the static element. First element and the 8th element are having similar properties. Similarly, the second element to its 8th element, third element to its 8th element. Like that, every element is resembling the properties with its 8th element. So, in this manner, as like Dobereiner, Newland also constructed the new periodic table. So after that, what will happen? is it closed, and this law is appreciable and it was finalized, otherwise any other laws are came, let we will see. So here also some of the limitations we are going to observe. What are the limitations? This law was applicable to the elements up to calcium only. Only what? This law is applicable only up to the calcium only. It contained only 56 elements. Whatever the elements he constructed in the periodic table, how many elements are there? Only 56 elements. Further, it was assumed by Newlands that only 56 elements existed in the nature. No more elements would be discovered in the future. But we know that nowadays so many elements are discovering. After 56, so many elements we have, but there is no such place is given in this periodic table. There is the upcoming new elements are on coming days. So many elements are coming. So at that time, he closed the periodic table up to that end only. That periodic table was ended. For the upcoming new elements, there is no places given in this periodic table. He constructed the periodic table only for the 56 elements. Third, in order to fit the elements into the table, Newlands adjusted two elements in the same slot. So what he did is generally in a single slot, one, if you will see the Newlands periodic table, one element should be present in the one slot. But what he did is he tried to keep two elements in a single slot. Example, if you have seen cobalt and nickel are in the same slot, they are placed in the same column as fluorine, chlorine, bromine, which have a very different properties than these elements. Iron, which resembles cobalt, nickel in properties, has been placed different from this. It's so the major drawbacks, if you're going to observe limitations of Newland, if we will see what are going to happen. Generally, first one is it is applicable only for up to the calcium. There is no place for the upcoming elements. The Newlands table is having only 56 elements. And the third one, some elements which are having metallic nature, they are correlated. They are having in a similar column which is having non-metals. So non-metals and metals are kept in a same column itself. So because of that reason, the Newlands periodic table, what he has given, John Newlands periodic table law of octave, what he has given, is also having some drawbacks. So limitations once again, if we will see, so there are instances of two elements fitted into the same slot. Already we have discussed cobalt and nickel. Already we have discussed what is the single slot, single element should be present, but he kept cobalt and nickel in the same slot. Two elements should not kept in the same slot. Certain elements totally dissimilar in their properties. Already we have discussed chlorine, chlorine, bromine, along with metal, they have kept in same column. Because of that reason, what? It's not the particular same, the elements which are having dissimilar properties together kept in the periodic table, in his periodic table. Already it has given. For example, there is cobalt, nickel, palladium, platinum, iridium, which have different properties paired with halogens in the same row. That means what? Halogens, these hot metals like the cobalt, nickel, palladium, coinage metal, platinum, and these are all kept in a same row. So this is completely wrong. Why? Because those are metals, these are non-metals. It's not correct. So it was found that law of octaves holds good only for the elements up to the calcium. Already we have discussed up to the calcium only. The periodic table. Law was not valid for the elements at atomic mass. Now, this is one of the new points. What we got here. This law was not valid for the elements at atomic mass higher than the calcium. So what he's saying, the atoms, the elements which are having the atomic mass more than the calcium. So this law was not applicable for the elements which are having the atomic mass higher than the calcium. Similarly, already we know that Newlands periodic table was restricted only 56 elements, and there is no place for the new coming element. There is no room for the new elements. If any new element is discovered, new element is invented, what will happen? There is no place for the Newland law of octaves. Because of that reason, this law also getting some drawbacks. But we can really appreciate Newlands. Why? Because we have appreciated what? Whom initially? Dobereiner. Why we have appreciated Dobereiner? Because of the reason he is the first person to give an idea to arrange the or classify the elements in the form of a periodic table. But he, Mr. John Newlands given the idea in order to construct the periodic table based on the idea of what? The elements which are having similar properties. Those elements we should keep in one rack. We should keep in one row. We should keep in one column. That means the idea he got. The elements which are having similar properties, there may be a chance to keep those similar properties elements we can keep with similar rows. This idea is given by the John Newlands itself, and at the same time this John Newland's law is compared with the Indian musical notes. That I said forgot. So what is Indian musical note system? If we will see in our Indian musical note system, we know that Sari Gama Pada Ni Sa. So once you count from Sa onwards, Sa, Ri, Ga, Ma, Pa, Da, Ni, Sa. So Sa again is coming the eighth time itself. Re again it is coming once again if you pronounce Sa Ri Ga Ma Pa Da Ni Sa. That means what? Sa first element. Again the Sa is coming as what? Eighth element. Both letters are same or not? Similarly, the first element what we have taken, that is taken as Sa. Again the Sa is coming at which place? Eighth place. That means both are same. Sa both are same. Re both are same. Like that, every element, every musical note is resembling at which? Its eighth place. Similarly, the element is also resembling its properties with its eighth place. So that's why the Newland's law of octaves is compared with the Indian musical note system. Right, fine. Next. So now a new scientist has came. He is Mr. Mendeleev. So after completion of the periodic tables of John Newlands as well as Dobereiner law of triads, one of the new scientists came into the theory. He suggested a new periodic table on his views. What are his views and what ideas he given? What type of periodic table he constructed? Any defects, any appreciations? What are the merits and what are the demerits? Let we will discuss. We'll see. So once again, students remind, already we have completed why we need to classify the elements. That's the first thing. Second one is Dobereiner law of triads, as well as we have completed the John Newlands periodic table. So those two are also have some drawbacks. Because of that, new scientist has came into the theory. He was Mr. Mendeleev. So if you will see the regarding Mendeleev, Mendeleev classified the elements in the increasing order of their atomic masses. Observe students, the third periodic table is also addressed, especially based on the increasing order of their atomic masses. I mean what? Dobereiner also taken the same thing. Newlands also taken the same thing. And Mendeleev also following the same. That is what? Increasing order of their atomic masses. By means what? Till the Mendeleev periodic table, there is no finding of atomic number. Find out shell. Because of that reason, they have taken especially atomic masses, and he constructed the periodic table increasing order of the atomic masses. Similarities there properties. Oh, right. Next, he constructed the periodic table increasing order of their atomic masses. Fine, but especially the periodic table was constructed based on that. And what he has taken, the formula of the oxides, hydrates formed by the elements was also on the basis of the classification of elements. The classification of elements has also been done based on the formation of the oxides. The elements which are present in the periodic table. For example, hydrogen is there. Hydrogen formation of oxide, H2O will be. For example, carbon is there. CO will be. CO2 will be. Like that, the element is taken as R and oxygen is O. Like that. For example, if we have taken CO, we can call it as RO. CO2 is there, RO2 we can call it. For example, sodium is there, Na2O. For example, magnesium is there, MgO. That means RO, R2. Similarly, hydrates if we have sodium hydrate means NaH. So similarly, based on the formation of oxides, based on the formation of hydrates, the basis of the classification elements has been done. Once you see here, groups. First row, if you're going to observe, 1, 2, 3. Roman numbers I am reading right now. 1, 2, 8.
columns are. Similarly, the horizontal rows, we are going to observe 6 rows are. So this is the periodic table, how he constructed. Let me discuss later. But the second row, if you are going to observe, we have the oxide and hydrate formulas of what we have discussed right now. See once there, R2O, RO, R2O3, RO2, R2O5. Like that, R is nothing but the element which is present in the column. Oxygen, it is forming with oxide. RH means nothing but it's hydride. It's hydride, RH, like. So based on the formation of oxides, based on the formation of hydrates, similarly, in the increasing manner of their atomic masses, Mendel constructed the periodic table. Let's go with the Mendelic periodic table, how he has constructed and what factors are present. Mendelic periodic table has 6 horizontal rows called periods, 8 vertical rows are called groups. Once we will see how many rows we are going to observe. Periods. The downward arrow mark is here. First column low, third box. If you see here, 1, 2, 3, 4, 5, 6 numbers are there. So 6 horizontal rows represents 6 periods, and every period can be classified into 2 series. That means total we will get 12 horizontal rows. But here can be represented 6 periods only. Every period have 2 series. It was not given, no problem. And what he said, 6 horizontal rows called periods and 8 vertical rows are called groups. Once you observe with the Roman number, how many groups are there? Vertical. Vertical in the sense columns, if you are seeing, we are seeing here. How many vertical columns are there with the Roman numbers? 1, 2, 3, up to 8 are. So 8 vertical columns, 6 horizontal rows are. Right, fine. So the groups 1 to 7 had 2 subgroups are called A subgroup, B subgroup. Once you see here, students, what happening? First group with the Roman number 1, if we will able to see with the R2O and RH, oxides of R2O and hydrates of RH. First column can be subclassified into 2 types of groups. Once you see there, A group and B group in the first column. The second column, you can see A group, B group, A group, B group. That means what? Groups what he has suggested with the vertical columns that was again classified into subgroups. That is what? AB subgroups of the next. Okay, group 8 had 3 rows of elements. The last group, once you see here, group 8 with the RO4, we are going to see ferrous transition series is there in the first row. Last column, we will see transition series. That in the fourth series, if you are going to observe, ferrous, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. That means what? In the last 8th group, what he is saying, group 8 had 3 rows of elements. We have 3 rows of elements or not? Ferrous, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. Right. Elements having similar properties were placed in the same group. So one of the best thing we need to observe in the Mendeleev periodic table. The elements which are having similar properties were placed in the same group. What the initiative is taken from Newlands. There are some spaces left vacant in the table to accommodate the elements discovered. So this is the best thing which we are going to observe in the periodic table. What is that? Already we have discussed in the Mendeleev periodic table, Newlands periodic table. There is no chance for the new coming elements, but this Mendeleev, what he did, any new coming elements is there, upcoming elements is there. After my period, new elements will be discovered. So those upcoming new elements, some spaces left vacant in the table to accommodate the elements to be discovered in the future. By means what? Especially if we will see generally what happened in Newlands periodic table, if you are going to see, we can say that there is no chance, there is no vacancy, there is no place, there is no slot can be provided in the Newlands periodic table. But the best thing, the drawback which has came in the Newlands periodic table that was corrected by the Mendeleev, any new coming element will be there. There
that for that new coming element, a space is provided in his periodic table to accommodate. So it could be discovered in the future. So I am giving the place for that. He told that. Once if we will see here, what is the element he has given? Generally, if we will observe in the second group, once you observe here, everybody, third group once we will see. Third group, if you are going to observe, if Eka aluminum is called gallium, Eka silicon is called germanium. Eka aluminum is called gallium, Eka silicon is called germanium. Once we will see in the fourth horizontal row, we have two elements. The third column, which is having the oxides of R2O3 and RH3, we have two elements. What is that? Scandium and gallium. Actually, gallium is not discovered at the time which Mendeleev have proposed the periodic table, and the third period element is present above the gallium slot. What is present here? Aluminium. Because of that reason, Mendeleev suggested that in coming days, in the future, one element will definitely invented, and that element will be placed at the place of below the scandium or beside of zinc. So, if based on that, he has given the name, a new name. Anybody don't know that the element name. What are the properties of? But might be the element properties as be like aluminium. Because of that reason, he has given the name of gallium, Eka aluminium. And after knowing the element, the Eka aluminium is given with the name of gallium. Similarly, if we have seen the next row, beside of the aluminium, silicon is there. At the place of gallium, in the same row, germanium is there. Similarly, germanium also unknown element only when Mendeleev was proposed the periodic table. So because of that reason, the properties of germanium will be maximum equal to or similar to the silicon, he assumed. Because of that reason, the element which may be come in the future in place of germanium, he said that it is Eka silicon. And finally, after finding of the element, because silicon is named as germanium. Like that, similarly, boron, if you will observe, scandium, if you will see above the gallium, what it is present, that it can be taken as Eka boron. That is in the second row, third column, boron is having with atomic mass of 10.81. So the scandium was not invented at that time, and he considered as what? One new element will come at that place definitely, and that element will have the properties similar with boron. That's why he has taken that Eka boron. That's why it can be considered as scandium. So Eka boron is can be considered as scandium, Eka aluminium is gallium, and Eka silicon is germanium. So this is the best thing we can appreciate really, Mr. Mendeleev. Why? Because there is no elements are found at that time, even though he told the properties of that, which type of oxides it can form. So gallium at that time we don't know that. Eka aluminum is saying. So what are the properties he say? One element will come. Definitely it is also try to form the oxides like R2O3. How aluminum is going to form Al2O3. In the similar manner, what I said the name Eka aluminum, that may also form the oxides like R2O3. That may also form like the hydrates of RH3. Similarly, germanium, what is that? Eka silicon, what he said. Similarly, it forms the oxides like RO2. It forms the hydrates like RH4. So in this manner, he suggested the properties. He suggested the densities. He suggested the melting points. So these are all the values after finding of the new elements. Almost 99% the values what he suggested regarding the densities or formation of hydroxides or melting points, boiling points. These are all the physical properties also almost became equal. Because of that reason, really we can appreciate Mr. Mendeleev. So finally, once again, if we will see in the Mendeleev periodic table, how many groups are there, children? 8 groups are there. How many periods are there? 6 periods are there. Every period is can be classified furtherly into 2 series. Means 12 series will be there. After that, every group can be divided into subgroups. In the eighth group, we are going to observe 3 rows are there with the metals, and he is given place for the new upcoming elements. It's now merits of the Mendeleev's periodic table. Already we have discussed. Once again, we'll see any information if we have missed. Elements were classified on a more fundamental basis of their atomic masses and properties. So the major thing, if you're going to observe here, elements were classified. Till now, elements are classified based on the atomic masses only, but we consider the properties also. Spaces were left vacant to accommodate the elements to be discovered in the future. The best thing we can appreciate in the future, any new elements are came. We can also adjust the elements in the periodic table left. Vacant positions are given for the new coming elements. It could be predict the properties of the elements which helped in the discovery of new elements. Similarly, the inert gas elements discovered later could be placed in the separate group without disturbing the table. I means what? Any new element is came, inert gases are came. The Mendeleev periodic table, what he has constructed, any element is not disturbed. They have kept in a separate column. That is the best thing we can appreciate. Why? Because there is no changes in the periodic table. That was separately kept in a separate column. Those what? Inert gases. So what are the, in these also some minor defects also we can able to see in the Mendeleev periodic table. What are those? Some elements are not arranged in the increasing order of their atomic masses. Generally, already we have discussed this periodic table also constructed based on their atomic mass increasing manner. But cobalt is placed before nickel. Tellurium is placed before iodine. Generally, if you are going to observe here, the Mendeleev periodic table is constructed based on the atomic mass increasing manner. Tellurium atomic mass will be 127.6 and iodine mass is 126.9. Based on the property atomic mass increasing manner, iodine should come first. Tellurium should come next itself. Once you observe here in the fifth row, sixth group and seventh group, if you will observe, tellurium and iodine is there, 127.60, 126.90. According to the property atomic masses increasing manner, 126 should come first, 127 should come later in ascending manner. But here we are going to observe the descending manner itself. Once you see, students, descending manner we are going to observe. Here it will be the 127 is the highest number and 126 is the least number. If we will able to see here, actually it should be in the increasing manner, but it is present in the decreasing manner itself. This is one of the drawbacks. Okay. Now, similarly, cobalt and nickel. Last group, once you see, ferrous, cobalt, nickel is there. Observe the atomic mass 58.93 and 58.71. Actually, 58.71 should be in the first, and after that, cobalt should come 58.93. But these are arranged in a descending order of their atomic masses. Tellurium and iodine also arranged in the descending order of their atomic masses. So these are the drawbacks, minor drawbacks we can observe here that can be corrected in the most less periodic. The next one, if we will going to see, position of hydrogen is not clear because it shows properties similar to metals as well as non-metals. Once we will see here, hydrogen is kept in first period, first column. Hydrogen is actually, hydrogen is a gas. It was kept in the column along with the elements of metals, soft metals, alkali metals like lithium, sodium, potassium, rubidium, cesium. I means what? Generally, hydrogen is not a metal. Hydrogen is a gas, but lithium, sodium, potassium are metals. So, with the metals, one gas is kept in the same column. I mean what? It shows properties similar to metals as well as non-metals properties. Because of that reason, why he kept the hydrogen. That means nothing but we can say that directly the hydrogen position is exactly not clear. The position of isotopes of elements is not. Isotopes means, you know that already. The number of protons are equal. Atomic masses will be different. Well, if we will going to observe the isotopes of hydrogen, deuterium, proton, tritium, like that. So the isotopes position cannot be clear in Mendel's periodic table itself. So these are the minor drawbacks we are going to observe in the periodic table. By means what? The first periodic table of the Dobereiner law of triads. Second one is Newlands periodic table. Third one is Mendel's periodic table. So finally, we got a clear idea regarding the periodic table based on the properties of the elements. Mendel have given a particular idea. We can construct a periodic table right itself. So finally, after completing of this periodic table based on these minor drawbacks, one more scientist came, Mr. Moseley. That is called as modern periodic table. Henry Moseley gave a new property of elements, atomic number. This was adapted as the basis of. So clearly we can say that the one of the new topic, that means nothing but the periodic table is constructed, but the property what we are considering here, till the Mendeleev periodic table we have taken atomic masses, but whereas here we are considering atomic number. This was adapted as the basis of modern periodic table. Modern periodic law, modern periodic table, definitely we will discuss tomorrow itself.